So now we want to start looking at absolute values and graphing them in general. So first off, I want you to think about what the number out in front normally is representing, right? That number is typically your A value, and it's talking about a vertical stretch, and that is still what's happening here. So under the transformations, we could say vertical stretch of 2. And we'll get more work with that in the next couple days. So that means if we were to graph f of x, okay, so we're going to use the parent function, okay? So the old function that we had was like this, right, from our last graph. So if we were doing 2 times f of x, it would just be 2 absolute value of x. So if you were thinking about our y values way up here, okay, 3, 2, 1, 0, 1, 2, 3, you just multiply all of those by 2. So this would become 6, 4, 2, 0, 2, 4, 6. Okay. If you think back way back when we did transformations, remember we always just took our y value and multiplied by 2. So all the way to the left, if it's 3 times 2 is 6, 2 times 2 is 4, 1 times 2 is 2. Okay. And again, we're going to get way more work with this later. So our vertex is still at 0, 0, right? That's where it changes from increasing and decreasing. Our axis of symmetry is x equals 0. It's that vertical line that cuts it in half, right? Which in this case is at 0. Our domain, which is always going to be the case right now, is negative to positive infinity. All the x's are going to be accounted for. It's the y's that aren't. Our lowest y value is 0, and our highest is infinity. Remember, these are x's and parentheses. So again, you always think about your axis of symmetry cutting in half. So on the left of it, it is decreasing. On the right of it, it is increasing. So if I'm decreasing on the left, that means from negative infinity to 0, we are decreasing, which means from 0 to infinity, we are increasing. The axis of symmetry just cuts it directly in half. One part will be increasing, one part will be decreasing. Now it says, how did the domain and range compare to the parent function? Well, if we think back to up here where we did this on the last one, okay, domain and range in the orange and green, right? Exactly the same. Exactly the same. And that's always going to be the case when it's just an A value. So on this next one, we have negative 1/3 f of x. So negative 1/3 absolute value of x. So again, our parent function, I'm just going to graph that quickly here. That's what we started with. Our transformations this time is a vertical condense or compress of 1/3. And remember, when it's negative, we are reflecting over the x-axis. It doesn't matter what order you do this in, but I'm just going to focus on the left one. So it's at 3, divided by 3 is 1. So that would be here, but then we need to flip it. So it goes down here. It's at 2. 2 divided by 3 is 2/3, which is right here, but then we got to flip it. 1 divided by 3 is 1/3, then we flip it down here. And 0 divided by 3 is 0, and you can't flip it. So essentially what's happening is it's just flattening out over here, like this. Again, we'll get more work with it. So our vertex is still at 0, 0, right? And our axis of symmetry is still at x equals 0, or the y-axis. Remember, that's going to cut it in half. So if we focus on the green, it is increasing on this side and decreasing on this side. Our domain is still going to be the same. It's still going negative to positive infinity. But this time our range is different. Our lowest y value is negative infinity and our highest is 0. So your range changes. Remember, with increasing and decreasing, these are always x values with parentheses. So again, like I said over here, it's increasing on the left, decreasing on the right. So on the left, farthest left is negative infinity, farthest right is 0. Farthest left for decreasing is at 0, farthest right, positive infinity.